In this example, we're going to find the Taylor series for the function f of x equals cosine of x around x equals 0. So first, we're going to need to find, we know that, let's put down the formula here. So f of x is the sum from 0 to infinity of the nth derivative of x, in this case at 0, over n factorial x minus 0 to the n. Okay, so we have a formula here, but we need all of these derivatives of f at 0. So I'm going to just make a little table here. So we're just going to see if we can figure out what's going on with the derivatives. So we'll do a few of them. 6 might be enough. We might need to go to 8 or 9. The 0 derivative is cosine of x. The first derivative, or the derivative of cosine of x, is going to be negative sine of x. Derivative of negative sine is negative cosine. Derivative of negative cosine is positive sine. Derivative of sine is cosine. And you notice that we're back to the beginning, right? So we're going to get negative sine again, negative cosine. And if we want to go 7, 8, 9, we're going to go sine, cosine, and then derivative of cosine is negative sine again, etc. If we evaluate these now, and it's periodic, right? So every fourth guy we get here we've got a cosine x, here we've got a cosine x, here we've got a cosine x, right? So it's periodic. Now if we plug in x equals 0, cosine of 0 is 1, sine of 0 is 0. So we've got this pattern, 1, 0, negative 1, 0, 1, 0, etc. So half of these are 0, and they're 0 when n is odd. Okay, so we're only going to use values of n that are even. Next, we're going to notice that we alternate between positive and negative. Okay, so we're going to have to take that into account too. All right, so when n is equal to 0, we're going to have the 0th derivative over 0 factorial x to the power of 0. When n is equal to 1, we want to drop that because the derivative is 0. When n is equal to 2, we're going to have the second derivative divided by 2 factorial x squared. So it makes sense that we only iterate through n's that are even, we drop the odd ones, and we can do that by changing this n to a 2n everywhere. So we're going to go the sum from 0 to infinity of f2n at 0 over 2n factorial x to the 2n. And so what this does is it iterates through all of the even terms. So n is equal to 0, we get 0, right? 2 times 0. N is equal to 1, we get 2 times 1 is 2. N is equal to 2, we get 2 times 2 is 4. So this only gives us even terms, and it excludes the odd terms. And so what we end up with here is the 2n derivative, which is either negative 1 or positive 1. So I'm going to put in negative 1 for a second. I'm going to worry about that sign in a sec. So when n is equal to 0, we want positive. When n is equal to 1, the second non-zero term is going to be -1. So in fact, I can use just an n here. So this is n equals 0. This one we're going to want to be n equals 1. This one we're going to want to be n equals 2, so on. But -1 raised to an odd power is going to be 1. -1 raised to an even power is going to be +1. And so this is going to do it exactly for us. -1 to the n over 2n factorial x to the 2n, and we want to sum for every n from 0 to infinity.